So this is the third video in the series of 3 videos on using standard form with a wave equation. We're going to be using the skills from the first 2 videos to be able to do this effectively using standard form with a wave equation, which is something that comes up in core physics, unit 1 physics. So here are the skills we're going to be using, and this is our ultimate goal. This is what we're doing in this video. So we can see why we need to use these very large, very small numbers here. We've got a massive range of numbers from 10 to the power of minus 12 for the wavelength, right the way through to 10 to the positive power of 3, and a massive range in frequencies from 10 to the power of 20 to 10 to the power of 4. Now you don't need to know this down the bottom, but it's quite interesting. This gives you a bit of background on the different wavelengths. If you've got 10 million degrees Kelvin, that's obviously very, very hot, and you tend to get these high energy, high frequency wavelengths emitted by objects that are doing nuclear fission or nuclear fusion. And you can see that these wavelengths match about the size of an atomic nuclei. The much colder objects you find in space, so cold areas of space, nebula and things, give out much lower energy, lower frequency radiation. So the equation we're going to be using is this: velocity equals frequency times wavelength, and this number here is our velocity. Velocity or speed, very similar ideas. We can call this, that number, people approximate it to that, they round it out, and it's really useful for you to remember that number. So your questions will look something like this in an exam. You can see you're being asked to find the frequency. You're given the wavelength. So first of all, let's write down our wave equation. So velocity is frequency times wavelength, and we haven't got any velocity. You can see why it's useful to remember the number from the last slide. So velocity is 3 times 10 to the 8. So let's rearrange this. We're being asked to find the frequency. So frequency is going to be equal to velocity divided by the wavelength. And all we need to do now is substitute in the numbers. So the velocity of light is 3 times 10 to the power of 8 meters per second. And the wavelength we're given here is 690 nanometers. Oh dear, we need to try and convert that. So we know that 690 nanometers, we know that's nanometer is 10 to the power of negative 9. We saw in one of the previous videos, and so to convert that, we can move the decimal point 2 places. So we've got 6.9. We've made that number smaller, so we need to make the number larger here by 2 powers of 10. So there you go, that's the number we're going to use in our equation. Of course, that's meters now. So we've got 6.9 times 10 to the negative power of 7. We saw in one of the previous videos that to divide you need to take away the powers. So first of all we'll do our frequency. So 3 divided by 6.9 is 0.43. And then we need to take away the powers. Oh, this is a bit tricky. So we're taking away 8, take away minus 7. So a minus and a minus is a plus. So 8 plus 7 is 15. So our answer is going to be 0.43 times 10 to the 15 frequencies measured in hertz. Now there's a slight problem here with my answer, and that is that standard form requires the decimal point to be here. So I need to convert this and add a little step on the end. So I need to make the number larger here. I'm moving the decimal point there. So if I make the number larger there, I'm now going to make it smaller there. So my answer in standard form is that. Right, next question. First of all, start at the beginning, write down my wave equation. Let's see what I'm being asked to find out. So they want me to calculate the frequency. I'm given the wavelength, I know the velocity already. So the frequency is going to be equal to velocity divided by wavelength. And so I'm given the answer, I'm given one of the numbers in standard form, so I don't need to convert this, that's really handy for me. So let's see, frequency is my velocity, 3 times 10 to the 8, that's divided by the wavelength. Okay, so 3 divided by 4, 0.75. I've got this tricky little problem again. Let's write that down. So I need to take away the powers. So it's 8. Take away -7 as before. Minus and a minus is a plus, so that's 8 plus 7 is 15. Frequency hertz. And that is not standard form, so I need to move the decimal point one step in that direction. So I'm going to make the number larger by moving it that way. So I need to make the power 1 power of the 10 smaller. Again, answer in hertz. Oh, purple light. So this time they're asking me to calculate the speed. Well, we've just been saying on the last slides that we've memorised the number for speed already. So you could just write the number down if you know 3 times 10 to the power of 8. But if this question was worth 3 marks in an exam, I suppose you'd want to show off your skills a little bit and show that you've earned those 3 marks. So start at the beginning, we write down the wave equation again. So velocity, frequency, times wavelength. And what am I being asked to find? Velocity. I don't need to rearrange. Great. So my frequency is 5 times 10 to the 14. And then what do I need to do? Multiply it by 6 times 10 to the minus 7. I'm showing my substitution here. I get a mark for that, so that's great. And so I'm multiplying. So 5 times 6 is 30. And then I need to work out what's going on with my powers. Right, so I'm saying 14 is my 1 power, and multiplying, so it's 14 plus minus 7, plus and a minus is a minus. So 14 minus 7 is 7. Is my answer in standard form? No, the decimal point is in the wrong place. So let's move it to the correct place. So by moving that decimal point this way, I've made the number smaller by 1 times power to the 10. So here I need to make the number power larger by 1 power of 10. Oh, units, silly me. So velocity, meters per second. So there's a question for you to try yourself.